Welcome to this lesson where we are going to discuss multiple representations of functions. Functions can come in many different ways. We could use an equation to represent a function. An equation that we typically see is our slope-intercept form. We have y equals mx plus b. We'll touch on that later. You can use a table where you'll typically see x and y values. They can be any letters, really. X and y values translate easily to a graph. Before we dive in, I'm going to touch on the first examples that aren't too bad. This says, a manager at an amusement park monitors the ticket sales at the park over a 4-day weekend. Match each situation to one of the following graphs. Sketch a possible graph of the situation if the situation does not match any of the given graphs. So option 1, we have the park was closed Friday for repairs. So if I look to each graph 1, 2, and 3, which graph would represent the park being closed Friday for repairs? I would say graph 2. It looks like there were 0 sales on that Friday, which would indicate that it must have been closed. Option 2, the park hosted a big concert on Saturday and a parade on Monday. As I look at the other graphs, I see graph 3 with high sales on Saturday and Monday, indicating they must have had an event that got them a few extra sales. And number 3, the park was very busy during the holiday weekend. All 4 days are in high value in sales, so I would attribute that to graph 1. Now we're going to dive back more into a table, equation, and graph. A table, we talked about, are x, y values that we get to create. An equation could be referring to the form y equals mx plus b, where m is equal to the slope, which our slope formula, if you remember, is y2 minus y1 over x2 minus x1. I'm sure you've seen that before. The b in the equation represents the y-intercept. If we were to take a look at a graph, so say we have a graph with an x-axis and a y-axis, any point along this graph, if I were to, that's a y-intercept because it touches the graph. The x value is 0. So your hint, the y-intercept happens when x equals 0. Let's dive into an example. We have a problem. Kurt is rappelling down a 500-foot cliff at a rate of 6 feet per second. Create a table, equation, and a graph to represent Kurt's height from the ground with relation to time. So let's start with creating a table. We know that he's going down a 500-foot cliff at a rate of 6 feet per second. Where we have two things going on here. We have time, that's going to be our x, and we have his height. So at time 0, when we create a table, we can choose the x values. I'm going to start with time 0, then after 1 second, 2 seconds, and 3 seconds. So at time 0, he's still 500 feet high. he's rappelling down a 500-foot cliff. So he starts at 500 and starts making his way down. He goes at a speed of 6 feet per second. So after 1 second, he will be at a height of 494 feet. After 2 seconds, it will be 488 feet. And after 3 seconds, he'd be at 482 feet. In a table, you only have to make 4 values. Now let's say we need to come up with an equation. Remember, y equals mx plus b, where we can use 2 of the points to come up with the slope. Now that slope formula from the previous page was y2 minus y1. So let's subtract my y's, 494 minus 500, over x2 minus x1, so that'd be 1 minus 0, which would leave me with negative 6 on the top divided by 1. So my slope is negative 6. So in my equation, I'm going to put that in for m. So we have negative 6x. And then we need the y-intercept. Well, if you remember my hint, the y-intercept always happens when x equals 0. So if we go back to our table, we have an x value of 0 right here. What's the y value there? It's 500. So we'd finish this equation off with plus 500. Now we can make a graph, but I'm going to use my equation to help us answer the question before we make the graph. Because it says, when will Kurt reach the ground? He will reach the ground at a height of 0. So whenever we get a 0, we're looking for what time would that be. We have a lovely equation to help us. If we replace the y value with a 0, now we can solve this equation for x. I'll subtract 500 on both sides. We get negative 500 equals negative 6x. Divide by negative 6. And we get x equals 83.3 seconds. So at 83.3 repeating seconds, he would reach the ground. Now the one thing we haven't done is created a graph yet. So let me make some space so that we may create a graph. So to represent this, we really only need our x and our y-axis. And on the y-axis, we need to get up to 500. So I'm going to go by each tick mark represents 100. 1, 2, 3, 4, 5. There's 500. And that's the y-intercept. So that's the first point on the graph I can plot. Now the time in seconds, when the y value is 0, that's along the x-axis. That's at 83.3. So let's go by tens. 20, 30, 40, 50, 60, 70, 80. And we can estimate that his graph would be about right here. We can connect the 2 points, and there is our graph.